Okay, just like the product rule is not just find the product or the derivative of the first and the derivative of the second, multiply them. You actually have to do the rule 1d2 plus 2d1. Same thing with a quotient. You cannot just find the quotient of the top, the quotient of the bottom, and divide them. So we do have the limit of the quotients, the quotient of the limits, but that does not work for derivatives. Again, the proof of this is in the auxiliary section of the book. You don't need to know the proof. If you're interested in it, please go there to see it. What I need you to do is learn the rules. So what I'm going to do, I know it's called the numerator and the denominator. A lot of people call it the top and the bottom. Right now, I'm going to call it the high and the low. Okay, and so f of x is the high function. F prime of x would be the derivative of the high function, which I'm going to call d high. G of x would be the low function. G prime of x would be the derivative of the low function, so I'd call that d low. So if you look at this, you see g of x times f prime of x minus f of x times g prime of x all over g of x squared. Yes, the quotient rule is not fun at all. So what did my students like to do to try to make it a little bit easier to understand? They remember low d high minus high d low over what's below squared. I'm going to say that one more time. Low d high minus high d low over what's below squared. And the order in the numerator absolutely matters. Subtraction is not commutative. 5 minus 2 is not the same thing as 2 minus 5. So you have to do the bottom times the derivative of the top minus the top times the derivative of the bottom. It has to be the bottom times derivative of the top first, or you're not going to get the proper answer. This almost always has a lot of simplification involved when you're finding the final answer. So just be comfortable with your algebraic skills. Remember how to multiply things out. Remember how to factor and simplify. Always necessary with the quotient rule to at least try. So how do you find, it says steps for the product rule. Hopefully this isn't still the product rule. This should say steps for the quotient rule. Steps for the quotient rule. First thing you want to do is identify the high function, derivative of the high function, low function, derivative of the low function, and then you're going to plug it into low d high minus high d low over what's below squared. So let's go ahead. Then once you do that, always try to factor first, then distribute. I'll show you how to do this, but let's look at this. We're going to start off with, the low function actually. Then we're going to find the derivative of the low. We're going to find the high function. Then we're going to find the derivative of the high. Remember, the derivative, because this is a quotient, this is a fraction, is going to be equal to low d high minus high d low over what's below squared. So the low function here is 5x minus 2. The high function here is x plus 4. Oops, sorry, let me rewrite that. There's x plus 4. Let's think about what's the derivative of the low function. Well, the derivative of 5x minus 2, hopefully that's very easy. It would be 5 times 1, which is 5. The derivative of negative 2 is 0 because it's a constant. The derivative of x plus 4, well, the derivative of x is 1, and the derivative of 4 is 0, so that would just be a 1. So what we're going to do here is low d high minus high d low over what's below squared. Let's go ahead and plug that in. So y prime would equal the low function, which was 5x minus 2, times the derivative of the high function, which is a 1, minus the high function, which is x plus 4, times the derivative of the low function, which is 5. Never ever forget, all of this is over the low function squared. The low function here was 5x minus 2, quantity squared. Never ever distribute out that denominator. It's not worth your time. So always leave that denominator in factored form, but we absolutely do need to work with the numerator. So the numerator, I'm going to start multiplying things out. So I'm going to multiply the 1 through. Well, that's pretty easy. But then I'm going to multiply the 5 through to both terms. I'm going to be really, really careful. I'm going to highlight it. You must distribute your negative. You must distribute that negative. So be careful with distributing the negative. I'm actually going to do this in 2 steps for you so you can see me distributing the negative. I'd be okay with you doing it in 1 step, but I'm going to do it the first time in 2 steps so you can see what I mean by distributing the negative. So 5x minus 2 times 1 is, 5x minus 2. And then I'd have minus 5 times x plus 4. 5 times x is 5x. 5 times 4 would be plus 20. And all of this again is over 5x minus 2 squared. Never ever distribute at that denominator. It's not going to help you out. Now I need to distribute that negative, and it's so important. Remember to distribute the negative. I'm going to write a little note. Remember to distribute the negative. So important that you remember this. This is one of the biggest mistakes on the test for students who aren't comfortable with their algebra. So I have 5x minus 2 distributing the negative. I would have a minus 5x. Distributing the negative, I would have a negative 20. A lot of people would have a positive 20 on that one. I have 5x minus 2 quantity squared on bottom. I'm still messing with that top, right? I see the 5x's cancel. I can combine like terms. If I combine like terms, I'm ending up with the derivative y prime equals, well, negative 2 minus 20 is a negative 22. This is all over 5x minus 2 quantity squared. Nothing in common, nothing simplifies any further. There's our final answer. Again, you never need to distribute out or FOIL that denominator. Always leave it in factored form. It helps you with the simplification, and it's just a waste of time. Another error you can make if you try distributing it. So there it is. That's it. That's your quotient rule. Low D high minus high D low over what's below squared. Just be careful with your simplification. I did want to go back and notice in the product rule I told you, hey, some of these problems we actually wouldn't need to use the product rule. The only reason we would use the product rule is because it specifically stated you have to use the product rule. Well, on this problem we didn't have any options. We had to use the quotient rule on this one right here. The quotient rule, because it's a fraction, this fraction doesn't simplify. It's not a single term on bottom, so we can't separate it and simplify it like we did in the previous section. We have to use the quotient rule on this problem. I also want you to remember finding the equations of a tangent line. You guys done this. This is going to be, I told you, on every single test. A derivative is the slope of the tangent line. And so the idea is we're trying to find the rate of change. That tangent line is extremely important in applications, so we definitely want to be able to find the equation of a tangent line. So if you remember, you always need to find an equation of a line, you need a point and a slope. And remember, the slope here is the derivative, but then we just plug in the given x value. And then you always plug it into y minus y1 equals m times x minus x1. So this is a process that you've got to remember. I'd be putting it on my note card if you're allowed a note card. On your exams, you've got to remember how to find the equation of a tangent line. Very, very, very important. Why am I saying that? Because that will be our next question.